The Dirt with me, Mike Howell, an eKonomics podcast where I present the down and dirty agronomic science to help grow crops and bottom lines. Inspired by eKonomics.com, farming's go-to informational resource, I'm here to break down the latest crop nutrition research, news, and issues, helping farmers make better business decisions through actionable insights. Let's dig in. Well, hello again, everyone. Welcome back to The Dirt. We've got another episode I think you're really going to enjoy today. We've went around this topic several times. We've mentioned it, but we really haven't spent a lot of time digging into it. I thought today we would spend a few minutes talking about manure and manure management. Now, manure is something that is going to be different depending on where you're located. There's different types of manure, and we'll get into all of that here in a few minutes. But to help us talk about manure and manure management, we have two guests here. Both of them are from Penn State University. We've got Dr. Rob Meinen and Dr. Charlie White. Gentlemen, welcome to The Dirt.
Hi there. Thanks for having us, Mike.
Yeah, great to be here.
Let's start off and find out a little bit more about our guest. Rob, if you will, tell us a little bit about yourself and what you do there at Penn State.
Thanks, Mike. I am the director of our state nutrient management education program. I have a good background in the swine industry, but I've been at Penn State for almost 25 years, working with manure and nutrient management issues. And I have done a lot of work with our commercial manure hauler and broker program, as well as our nutrient management program. We also have some odor regulations in Pennsylvania that center around livestock and manure issues, and I get involved with those as well.
Okay, and Charlie, tell us a little bit more about you.
Yes, so I am the extension specialist for soil fertility and nutrient management at Penn State. I deal with a whole range of nutrient inputs, whether that's fertilizers or whether that's manures, whether that's crop rotations that include cover crops or previous legumes, really a very holistic view on nutrient inputs and how to effectively manage those. I do work closely with Rob on the nutrient management education program. I work closely with our agronomy extension team to provide recommendations for farmers. I teach the soil fertility course, and Rob and I co-teach a nutrient management course for undergraduate and graduate students at Penn State.
I want to get in and start talking about manure a little bit. I know it depends on where you're located is the source of this manure. So let's talk a little bit about some of the different sources. And just to clarify things, we're kind of going to talk about manure, but we'll also include things like chicken litter, poultry litter in that as well. We'll lump it all in together. I'm not sure technically if there's a difference in that. Maybe we can get into that a little bit as well. I'm based in South Mississippi. I've been here most of my life, and I live in the middle of one of the biggest chicken producing places in the country. We have a lot of poultry litter. I've had a little experience with some dairy manure as well. So what is the main source of manure there in Pennsylvania, and what are some of the other sources of manure that we deal with around the country?
We have it all in Pennsylvania, right? So anytime we have animals, or you're going to put something in the front end, you can do something out the back end. So we can lump all those definitions and species that you mentioned into that definition of manure. So that would include the urine, the feces, but also bedding material that would go into a lot of those products. So we have liquid systems and we have dry systems, right? Solid systems. And in Pennsylvania, we do a lot with dairy manure and swine manure on the liquid end. But on the solid end, we have a well-developed broiler and layer industry in the chicken world, and we have equine farms as well. So we kind of deal with all of it.
And more too, some of our dairies are transitioning into beef production, and so a lot of the beef cows have solid bedded pack manure as well. On the poultry side, we've got a decent-sized duck industry, and so that duck it's a poultry species, but typically their manure is handled as a liquid in terms of their production systems. We've got a decent veal industry as well, and that's a very unique type of manure, fairly liquid manure there. So, yeah, as Rob said, we've got a little bit of it all, and sometimes a lot of it all.
Why are farmers utilizing this manure? I know that we've got some nutrient value to that. What is it just because of the nutrient analysis in that? And what nutrients can we obtain from this manure? So talk a little bit about what they're getting from the manure.
When you ask the question, why do farmers use manure? I feel like there's farmers that sort of fall into maybe two categories. One would be the livestock producers, where the manure is sort of a waste product from the livestock production enterprise on their farm. And in order to get rid of that waste product, the best way to do that is through land application. And in that case, their cropland kind of acts as a sponge for those nutrients, so to speak. So they wouldn't be able to produce those animals without a place to be able to put that manure. On the other hand, we've got farmers that don't have livestock, and in that case, manure is not seen as a waste product, but it's seen as a really valuable resource in terms of the nutrient content. And there are farmers that will pay to import that manure as a replacement for fertilizer. And so that gets into interesting questions of how much of the nutrient content in that manure do you credit based on what your crop needs are, which goes back to what your soil levels are. Is it more economically efficient to bring that manure in than it is to purchase fertilizer? So there's a lot of questions, a lot of agronomic and economic questions that go into those farmers that aren't producing the manure but are maybe purchasing it in as an alternative to fertilizers.
Yeah, I would add that manure brings some organic matter to the soil as well that commercial fertilizers do not, and a lot of people do favor that. They want to have that organic matter input to the soil so that their soil health becomes better, and they are increasing that carbon amount in their soil and allowing their soil to be more sustainable and more resilient as far as water and nutrient cycling goes. So they are able to have more resiliency with their crop production.
Here in my part of the world, some producers will put out chicken litter and they really love it. They see the increased organic matter. They get the nutrient value out of that. On the other hand, we've got some growers that will not apply chicken litter for anything in the world. They say that the chicken litter is full of weed seed, and we get a lot more weed pressure when we have that. And there's a big debate about that. I know my philosophy on that, but I wanted to ask you guys, what do you think? Is there weed seed in this manure or chicken litter, or is that increased fertility that's making some of these weeds more prevalent?
Oh, that's a great question. I hate to say, is it the chicken or the egg, right? It could possibly be both. I mean, I would say that the weed seeds are only going to be in the manure if there's weeds being fed to the animals. And I would say most of the feed mills are going to be working with higher quality grains, and they're going to be mixing up rations that are going to be low in weed seeds. So I don't necessarily see a lot of weed seeds being transported in poultry manure in our region. But then, look at some other types of manure, maybe horse manure, right? So are those horses out and they're grazing in the pastures, and are they eating weed seeds? Is it passing through their digestive system? Yes, it probably is. So maybe horse manure might be spreading weed seeds. And, is that horse manure composted? A lot of people say the manure is composted, but that's a pretty loose term when you hear many people using it. Technically composting would be a heated process, an aerobic process where the pile gets hot and it kills the weed seeds. But how hot is the pile getting? Is it being turned so that all parts of the pile are getting mixed in to kill those weed seeds? So I think it depends a lot on, what are the animals being fed? How is the manure being handled after it's produced in terms of killing off those weed seeds? And your point about increasing the fertility of the soil, increasing the weed pressure, I think that's a real issue as well. And, something that needs to be dealt with on the agronomic side in terms of managing the cropping system.
Charlie, I read a paper several years ago back when I was still working with Extension, and I couldn't locate that before we started this recording today, but it was talking about any weed seed that a chicken did happen to eat. When it went through the digestive process in that chicken, that it was going to grind that seed up. There would be no way that seed would be viable. And, you think about all the acids that's going through the rumen of a ruminant animal. What is that going to do to those seed as well? It makes it really difficult for that seed to be viable after it goes through the digestive process, no matter what animal it's going to be.
In our region, Mike, we don't have that concern. I never hear of weed seed associated with poultry litter, manure products. Part of that might be because of our abundant wood chip, right? Our wood product sawdust bedding material, which really doesn't carry the weed seeds into the barn from the bedding end.
Let's talk a little bit more about the litter. or the manure. One thing I learned when I was working with the chicken litter is all manure is not created equal. Rob, you mentioned you had the broiler industry as well as the laying poultry up there as well. Talk a little bit about the differences in these sources, how the nutrient content may be a little different depending on what the source is.
Well, the nutrient content is going to vary for a lot of reasons. Some of the bigger ones would be what goes in the front end of the animal, right? A layer bird is going to be fed a different ration than a broiler bird. So, obviously, the horse and the cow and the pig are all going to receive a different ration because that ration is formulated to precisely match the nutrient content and the needs of the animal for their growth, their best healthy production and welfare. So the animal themselves, right, what they take in impacts the system. Then on the other end, we have the bedding. Is there bedding involved, right? The litter associated with our birds here in the broiler operations is going to be primarily a wood product base, whereas our layer farms typically don't have any bedding involved at all. Those layer birds are in a system where that manure is collected in a raw form and dried off pretty quickly. So the nutrients are not escaping; they're staying in that manure and being collected and taken out of the barn pretty quickly in a dry form, and then moved to the field for land application. So the nutrient contents will also vary because one manure has bedding inputted, which will dilute the nitrogen and phosphorus and potassium values within the concentration of the raw manure, and the other one is just the raw manure that's being excreted straight from the bird.
And the chicken industry, is evolving and has different ways that in, say, a broiler house, the litter can be managed. Some companies are cleaning out the house after every flock, and what that means is there's been less manure deposited, and so typically the phosphorus content of that manure that's cleaned out after every flock is quite a bit lower than the companies that essentially refresh that litter for maybe 5 or 6 flocks, and they decake it, they maybe pile it up to compost and heat for a period of time to kill off any pathogens, but then they spread that back out. That litter that's been there for 5 or 6 flocks is usually very enriched in phosphorus. The other thing that can happen with that process is some of the ammonia can be volatilized every time that manure is sort of raked and moved between flocks. And so what we actually see with that type of manure is it's a little bit lower in the nitrogen and it's much higher in the phosphorus. And so, farmers can, in some regions of our state, farmers have options about what type of litter they can get. And they might say, hey, I really need to build up my phosphorus and I'm comfortable using commercial fertilizer for nitrogen. Let me go for that litter that's had 5 or 6 flocks on it. Or soils that are really high in phosphorus and they want more nitrogen, they can go for the litter that's only had 1 flock in it. So we have things like that going on that are little nuances as well.
So, Charlie, that brings up several things that I have learned or had experience with. You talked about the high phosphorus when we have several flocks going through that chicken house. And here in Mississippi, they used to say that the chicken houses got cleaned out based on the price of the chicken feet. A lot of people don't realize this, but chicken feet are actually the second most valuable part of that chicken. And when the price of the chicken feet go up, they want to clean that out and not subject those chicken feet to that manure as much. So that's when they tend to clean the chicken houses out. But back to the phosphorus, one of the first growers I worked with that was using chicken litter, I asked him, how much chicken litter are you putting out? He said, I'm putting out about 6 inches. He was putting out as much litter as he could get, and he was just piling it up on the fields and then working it in. He really didn't know how much litter he was putting out and probably had no idea how much nutrients he was putting out. A year or 2 later, we started analyzing some of his soil test reports, and the phosphorus levels were off the chart. So then the question becomes, how do you draw down these phosphorus levels if you're putting out too much of that?
Yeah, it can be really difficult to draw those levels down because crop removal rates are fairly low compared to, say, 6 inches of chicken litter, right? It could take several decades of crop removal. We have one extension educator on our team down in Lancaster County, and his father had chickens on the farm and spread a lot of manure. And then when he took the farm over from his father, they got rid of the chickens. I think he spent about 20 years cropping those fields before it got to a level where the soil test recommendations were calling for phosphorus again. So it's possible, but it does take a long time.
Charlie, something else you mentioned, you kind of brushed over it. You talked about composting. Now, I know some manure is composted, some comes straight out of the chicken house and gets spread that way. I'm not as familiar with the swine manure, but talk about composting and why that's important.
So composting is a process where you intentionally add some additional carbon to the manure if needed, right? So if it's a high nitrogen manure and it needs more carbon, you might need to add carbon. If you have manure from, say, a bedded pack scenario with cattle, there might be enough carbon in it already. But essentially what you need to look at the carbon to nitrogen ratio of that material, and you want about 40 parts carbon and 1 part nitrogen. Makes an ideal blend. And so then you essentially stack it in a pile, and that pile should be big enough that it can heat up, and you let that compost come up to temperature, maybe 120, 140 degrees. Would you say that's about right, Rob? Rob's really our composting expert.
Yeah, that would be correct, right? We'd expect that to approach 140 degrees Fahrenheit.
So it's going to hit that temperature, and then it might start to run out of oxygen, and the microbes are going to quiet down a little bit. It might lose some temperature. And then at that point, you want to somehow stir the pile, right? Turn it with a compost turner, get in there with a bucket loader, and push it over and rebuild the pile. That's going to re-oxygenate it, and it's going to heat up again. And essentially, you want to do that enough times that you've blown off about half the carbon through microbial respiration. And once you lose about half the carbon, it comes back down to a C-N ratio of around 20-1. And then that would be a very ideal compost to be able to spread out onto a field. At that point, it's probably ready to be spread. And some of the key changes that occur in that composting process is a lot of the nitrogen that might have been in the ammonium form will be converted into organic nitrogen, which is a much more stable form of nitrogen. That organic nitrogen doesn't release odors when it's spread on the field, so it's a good way to reduce the smell and odor from manure applications. It's less likely to be converted immediately to nitrate and leach out of the system, so it's a little bit more of a stable form of nitrogen. Now that said, it is slower releasing because you've essentially stabilized it through that composting process. So you're not going to get, in the first year, you're not going to get as much nitrogen value out of it as with the raw manure, but it has some advantages in terms of other properties. And over time, if you use this, you will build up your soil organic matter levels, and the nitrogen will come out more slowly over time. 2-3 years later, it will continue to be kicking out.
Oh, I like to say that organic nitrogen, whenever it's stabilized like that in the soil, it gives you some resiliency, right? Because it needs to be unlocked, if you will, by the microbial system in the soil itself, right? The decomposers in the soil are going to break down that organic material, and part of that is the nitrogen availability to the crop. So if you have that in the soil, you have some resiliency, right? That microbial process is going to be tied closely to soil temperature and moisture. So the times when the plants are ready to grow coincides with the time when that nitrogen is being broken down and provided to the soil system, into the solution, and then into the roots so we can capture it for the crop.
So it's kind of working like a slow release fertilizer product.
Yes, exactly.
Guess we could have said that from the start.
Okay. We've talked about the nutrients in there a little bit. How do we know exactly what's in a chicken litter sample or a manure sample? Talk a little bit about testing those products and what we need to look for.
Yeah, I think back to a few minutes ago when you mentioned the person you interacted with was putting 6 inches of litter onto a field, right? That gave me an instant alarm because I think most people are not managing that way anymore. We know now that having a manure management plan or a nutrient management plan really gives us a lot of benefit because we can get the agronomic and economic value from the nutrients in that manure and not treat it as just a waste product for disposal. And then also do long-term health and management of our soils, which in turn gives us long-term economic benefit from our crops. So part of that is testing that manure, right? The more data we have going into the balanced rate for the amount of manure we're going to put on a field, the better off we are. So testing that manure for N, P, and K, nitrogen, phosphorus, potassium content is crucial. It's also recommend that people test their soil, right? How much does the soil need? How much can we put on? And then we want to know the components of that nitrogen, phosphorus that will go to the crops. We also want to know the crop yield. What crop are we growing? What is the yield expectation of that crop? And we can get a balanced rate. And we recommend that for everybody whenever they're utilizing fertilizers or manure.
And the last thing I'll add to that, once you have that balanced rate, you need to ensure that your equipment is calibrated properly to hit that rate, right? And so, farmers have all sorts of different types of manure spreading equipment. Some of it's very old and the rate is not as certain, but there's still ways to dial that in, right? Spread a load, know the mass of material that was on that load and divide it by the acreage. That's a classic way to do it. Some farmers now have very fancy equipment that has rate controllers and it's all computer controlled, and they can go to any field and just type into the monitor exactly what rate they want, and then they go and the system controls itself. So we've still got farmers that are on both ends of that full spectrum.
I might add, though, as well, not every farmer wants to buy the equipment. And if you have a smaller tract of land, sometimes that equipment capital is not worth laying out. So everywhere you go in the country, if there's animals, you're going to have someone who can do this professionally. So we do have professional manure haulers, applicators, and brokers who could transport the manure to your farm and apply it at a pretty precise rate. They make a living doing this, so precision has to come with what they do, because they are not going to make a good living if they don't do things correctly.
Okay, so we talked a little bit about the benefits of using manure. Obviously, we get the nutrient value. We get some increased organic matter. Are there any more benefits? And on the flip side of that, are there any drawbacks to using manure?
Well, I would add that there seems to be the magic of manure that people talk about. Anytime we do an experiment, we compare manured plots versus ones that have just gotten the commercial fertilizer. There seems to be a little bit of a yield boost that we can get with manure. That probably goes back to the organic matter content, but also maybe the micronutrient content. Maybe, you're feeding the microbes as well as feeding the crop. So that seems to happen. Challenges with manure. You've got to have the storage. If you're importing litter, you've got to have a stacking area. You might have to have slightly different equipment. But, as Rob mentioned, you can always hire a custom hauler to come in and do the spreading for you. So I think it creates a whole new set of equipment and storage infrastructure needed for handling manure that, if you're not set up for that and you just traditionally always use fertilizer, there might be a little bit of investment required there.
I often view the topic of manure utilization as a three-legged stool, right? Two of those are the agronomic use of manure, the economic use of manure, which are crucial, right? You want to be able to maximize the agronomic and economic use of those nutrients at the farm. But the other one is whenever you dive into that, you also have an environmental responsibility, right? The nitrogen and phosphorus, if they move beyond the edge of the field, they do not do you any good agronomically or economically, but then they become an environmental liability. So if you ask about drawbacks of manure utilization, that is one of them, right? It's a societal issue where, as somebody utilizing the product, you have to do it correctly. You want to give yourself the benefit, but you also want to make sure that you're not causing harm beyond the edge of your property. You want to make sure you are building your soil, moving those nutrients and nitrogen and phosphorus to your crop, and not be on the edge of field.
And just to add to some of that environmental concern, one of the things that farmers that are generating manure are faced with is limitations on their storage capacity. And I'd say most farmers in our state have gotten to the point where they have about 6 months of storage capacity, but that means they're applying manure both in the fall and in the spring. And so that manure that's spread in the fall, unless that's for some type of small grain forage or grain crop that grows over the winter, that has a high potential for losses. So you need to pair those fall applications with things like cover crops. The other challenge I would say too is that the manure nutrient content, to some extent, it is what it is, and it doesn't necessarily balance with what the crop needs. So oftentimes it might be excess in phosphorus and potassium relative to the nitrogen. And so it's not as flexible as, say, fertilizer, where you can just, ask your retailer to make a custom blend that fits what your soil test calls for, right? You have to be a little bit more creative in terms of where you put that manure, what fields you put it on, maybe do some things to your manure to try and segregate the nutrients, like there's, separating the solids out, or there's thinking about as you unload a storage, like a swine barn that has the underfloor storage, they typically don't agitate that. So the first couple loads and the last couple loads are going to be really high in nutrients compared to the middle loads. And so thinking about where do I take that really rich manure, what fields are going to need the nutrients the most versus what fields need less. So there's an element of creativity that is required when you're relying extensively on manure as a nutrient source.
So I can't go anywhere today, can't go to a meeting or pick up a farm publication of any kind that I don't see something talking about regenerative agriculture. I'm not wanting to get off into a discussion about regenerative agriculture today. We've talked about that on a couple of podcasts. If you're interested in that, you can go back and listen to some of those. But what I did want to talk about today, and Charlie, you mentioned this earlier, there's two types of farmers. We have those that have the animals and the crops, and they're keeping the manure pretty much on their property. There's also people that have one or the other, and they're going to have to transport that manure to a different farm. Talk about the nutrient cycling there, and where these nutrients are going and the benefits of that, and things to watch out for that way.
Well, one of the things we see in our integrated industries, which are swine and poultry, is that a lot of farms enter into those contracts and build the barn on their property because they have the cropland and they know the value of the nutrients, right? So replacing that high fertilizer cost in an annual basis with the manure nutrients, whenever they become caretakers, those animals becomes very valuable to them. If they have more animals than they have land on a ratio basis, then they're going to have to export some of those nutrients, and that can become valuable for the surrounding community or whoever's down the road that can take that manure. The difference that is biggest, I think, is the difference between liquid manure and solid manure, right? The liquid manure is harder to transport a long way. So you have to have kind of that neighborhood ability, if you don't have the land yourself, to take those nutrients to support a couple neighbors with the liquid manure, because there's a lot of water in it, a lot of weight in the water. So the per pound of nitrogen, per pound of phosphorus, per pound of potassium, those macronutrients become more costly to transport further down the road. We see a lot of litter in our neck of the woods, and I know this is across the country, right? The dry poultry products can be transported further because you get more bang for your buck whenever you put them in a truck and move them down the road.
Rob, could I ask you to talk a little bit about some of your research on how you've seen different segments of the animal industry move the animals versus move the manure in terms of dealing with some of these nutrient excesses that might occur?
Yeah, so I'm involved with some projects termed manure shed, right? So what is a manure shed? Manure shed is on a small farm level, a little similar to what we've talked about. How many manure nutrients are produced by the animals at a farm, and how much land in the surrounding acres for the given crop that is typical to the area are required. So if you had 100 cows, how many acres of corn would it take to take those nutrients and be balanced so that we don't have surplus nutrients that are environmentally a liability? So we can look at that regionally as well, right? If we have an area where we have a lot of poultry being produced, or an area where there's a lot of swine production or dairy production, we can have that imbalance on a regional level. In Pennsylvania, we happen to have several industries that intersect each other, right? The swine and poultry industries both are embedded in the state and producing nutrients in some of the same areas. So we found over time, since the turn of the millennium, we've seen that the swine industry in our state has shifted the regions in which they are placing new animals. So they are moving new barns north and west in our state, which coincide with areas where the nutrients can be used more readily because there aren't as many animals there. It also has social impacts because these are less populated areas. So we have less interface between the farm and neighbors, so we have less odor conflict. We also know that the swine industry wants to move those animals away from other swine farms because of welfare and biosecurity reasons. There's less risk of transport of disease into a new farm if you're further away from other pigs. So we see that coinciding and complementing this idea of removing or moving the nutrients to an area where they're in need. So we have the social, animal welfare, and nutrient management aspects going into that. But the poultry industry hasn't moved as much. They've stayed central to where they've been located traditionally, but they have another advantage. They can shift that manure shed by moving their nutrients because it's solid manure. They can ship it up the road further to a farm that needs the nutrients, to land where they can replace fertilizers with manure nutrients. So we see one industry with a liquid manure shifting where the animals are. We see the other industry working with a complex, developed brokering system to move the litter or the manure products to areas where it's needed.
So, Rob, that brings up another point. I have been hearing more and more talk these days about separating swine manure. They're setting it up so that they can remove the water from that and actually apply a dry product and maybe use the water for an irrigation application or something like that. Can you talk a little bit about that and what's going on in that process?
I think manure separation gives us a piece of the puzzle, solving all the complex mass imbalance issues that we have, right? We have places where nutrients from animals are in surplus of crop need. So that creates a mass imbalance of nutrients, a surplus of the nitrogen and phosphorus. So it's easier to transport the solid portion, right? So if we can separate that into different partitioning of solid and liquid, that solid part is a way to remove or relocate nutrients. So that's big picture stuff. But on the farm level, I see more separation happening in the dairy industry because that manure is more fibrous, just because the diet is different than a swine manure. And a lot of that fibrous material can actually be utilized on the farm. It can be dried and transported. Swine industry is a little harder to capture because that solid portion of the manure is not as fibrous. It's harder to pull out, and there's a lot more liquid, more water content in the swine manure. So I think we'll see advancements in these manure treatment technologies as we move forward, and they will help us to put some of the pieces together of relocating and transporting nutrients down the road to where they're needed.
And obviously that if we're talking about separating some of this manure, that's going to have an added cost to somebody. Can we talk a little bit about the economics of that? Is that something that's going to be a stumbling block to if we want to start separating manure, or is the cost coming down on that so it's economical to do that?
So I would say that is potentially a concern, but a lot of times the farms are finding value-added ways to utilize the separated solids. So for example, on a dairy farm, they might be able to recycle that as bedding material, and then that's less bedding that they have to purchase. They might be able to compost that material and then sell it, in 40-pound bags at, to the Lowe's and Home Depots and garden centers of the world. And that's, a tremendously high value product if you can do that. I think there are ways that farmers are creatively gaining economic benefits that will offset the cost of that separation technology.
So there's one other issue that we've kind of went around several times here today, and with the poultry litter, and I know it's the same way with the swine manure or the dairy manure. For some reason, the neighbors just don't like it when you start applying manure. They don't like the odor that comes with that. Now, the farmer really likes that odor because he knows it's saving him money a lot of times. But talk a little bit about the odor. Is there anything we can do to help with that situation and not have the neighbors upset if we're making a manure application?
Well, there's a lot you can do. None of them are perfect, right? So odor is going to occur. That's part of living in the country. A lot of people want that green space. They want the farms around them. But whenever it comes to manure application, there's a temporary disruption in their ability to have that clean air in some cases, right? But that's part of it, right? It's often a temporary thing. Manure application is done just once or twice a year on most fields. So that odor source will be there just for a day or two We expect it to dry up. We expect liquid manures to infiltrate, and that odor will decrease over time. But what can a producer do? What can a farmer do? They can think about when they apply, right? Applying at times whenever there's something going on or people are at home. If they can avoid that, they should, because then they have less potential for conflict within their neighborhood, and everybody wants to be a good neighbor. We often see that we have what's called, think about a thermal situation where the sun is hitting the ground and you can see that kind of shimmer of the ground heating up in the morning. If we apply manure in the morning and it get the air that is right at the ground to heat up, it can take odor up away and above people's heads. And that's, not trying to fool anybody, but it's a trick we can use. So I often recommend that people start applying manure early in the morning close to their neighbor and move away if that scenario makes sense within a large field or within a landscape of a farm. That gives the manure during time to dry during the day. And sometimes odors are worst at night because that thermal inversion is a little bit worse where the air doesn't rise and it stays close. And as manure odors are emitted, they can congregate and become a little thicker, more concentrated and drift over to a neighbor and be more offensive. So, on the liquid end, we can inject manure. If you can inject manure, place it below the soil surface, well-proven technique to abate odor or reduce the amount of odor that's produced because the odor just isn't escaping. We have less surface area exposure to the atmosphere, to the free air stream, and the odors are not getting into the air. So we don't have generation of the odor, that can be transported to a neighbor.
Charlie, anything to add on that?
Well, just to reinforce the idea of injection, I'd say that's one of the most common ways that farmers that are in densely populated areas, are earliest adopters of manure injection technology. Their primary reason was for the odor benefits and keeping the neighbors happy. There's a lot of agronomic benefits as well in terms of capturing more of that ammonia in the soil as an available source. It also helps to prevent phosphorus runoff by getting that manure off of the soil surface. So there's a lot of agronomic and environmental benefits. But, when we started talking about this 20 years ago, those types of benefits weren't at the top of the mind for the farmers. It was really the social benefit of not offending their neighbors with that odor that drove most of the adoption.
Well, guys, we've spent a good bit of time here today talking about manure. I know we could keep going for several more hours, but is there anything really important that we've missed today that you want to bring out, or any closing thoughts you want to leave our listeners with?
Well, I would put in a plug for a tool that we have developed on our extension website, and Mike, maybe you can put this in the show notes, but it's called the Manure Economic NPK Value Calculator. And essentially what it is it's a tool to help a farmer through the math of figuring out whether they're better off economically purchasing some manure, right? Maybe that's some poultry litter brought in from a broker versus purchasing fertilizer. And it's kind of complicated to figure out the math on the economics because you've got to look at your soil tests and how much you need. You've got to look at the manure analysis. You've got to look at the price per ton of fertilizers that are your alternative sources. It's not fun to do all of that math, but we've created a nice little tool where you can just plug some of the numbers in from your soil test recommendations, price per ton of different fertilizers, your manure analysis, and it kind of tells you what your break-even price is on the manure in terms of whether that's a better deal than fertilizer or not.
Okay, yeah, then we can definitely put a link to that in the notes. That won't be a problem at all. Rob, any closing thoughts?
Well, I'd just like to reemphasize, remember that manure gives us that agronomic and economic value to our systems. And, whenever you utilize it, you need to think about the environmental leg of that stool and make sure you're applying it according to a plan, right? Every state is going to have some manure regulations that you should be operating under. And if you're not familiar with those, go to your local conservation professionals, your local university extension offices, and find out what the rules are, find out what the best avenues are to utilize tools like Charlie is talking about to find out how to get that best bang for your buck and benefit your soil and your crop system with the manure that you add.
Well, gentlemen, we really appreciate you taking time to visit with us this morning. I think we've covered a lot of ground here and stuff that our listeners can really take home and apply on their farm. Listeners, we really appreciate you tuning in today. If you will, stick around for just a few moments and we'll be right back with segment 2. Farming isn't farming without questions, and now there's a place to go for answers. At eKonomics, an entire team of agronomists is waiting and ready to help for free. No question is too big or too small. Visit Nutrien-eKonomics.com and submit your question with the Ask an Agronomist feature. Listeners, welcome back for segment 2. Really enjoying doing this section every week where we talk to an agronomist and ask them a question of the week. To help us do that this week, we have Lyle Cowell, senior agronomist with Nutrien, back with us today. Lyle, welcome back.
Thanks for having me, Mike. I appreciate this segment of your show. It's great to be able to answer some questions from the farmers in the field.
Lyle, we know you've been around for quite a long time and have a lot of experience up in the Canadian region, dealing with different soil fertility related issues. And the question I wanted to ask you today is, during your time working up there, what has been the most unusual circumstance you've come across involving soil fertility?
That's a good question. And, the most unusual one, and this is a bit from the left field, and probably the soil fertility question that confounded me the most, probably where I made the most mistakes in understanding it, is a very minor issue of manganese toxicity that we see in some of our soils. That is a problem that I misdiagnosed. Manganese toxicity looks exactly like sulfur deficiency in canola. In wheat, it looks a lot like potassium deficiency or even just drought in wheat. And I mistook it as a problem for other issues, sulfur deficiency, the first couple of times that I saw it in the field. Now, it's a minor problem, but it's a very important problem if you have the problem. And these soils have increased in acreage in the past few years. I see more and more pictures of it, get more questions about it. And where is it occurring? It's occurring in sandy, acidic soils in the northern prairies that have become more acidified over the course of crop production. So as they become more and more acidic, and these are quite acidic soils, pHs of 5 or less than 5. And in those conditions, manganese, which is an essential required nutrient, becomes soluble at toxic levels to the point that it reduces crop production. So that is most certainly the most perplexing soil nutrient issue that I've ever run up against in my career, Mike.
Lyle, that's an interesting situation. I can't say that I would have gotten that one right either. Lyle, we appreciate you taking
very wrong.
Lyle, we appreciate you taking your time to visit with us today. Always get a lot out of your answers here. Listeners, we appreciate you staying with us this week. If you have any questions about anything we've talked about today, you can always visit our website. That's Nutrien-eKonomics.com. Until next time, this has been Mike Howell with The Dirt. Hey guys, if you like what you heard today, do us a favor and share this podcast with someone else. It could be your neighbor, your friend, your crop advisor, or whoever you think would enjoy it. Your support helps ensure future episodes, so please like, subscribe, share, and rate the show wherever you're listening from.